Hi, welcome to Unit 4, Day 11, how to predict if a molecule is polar or nonpolar. In Part 2, we're going to learn a shortcut for predicting whether a molecule with two or more atoms is polar or nonpolar. So, as you recall from the last video, we've learned that we can use differences in electronegativity to determine if a molecule or with two atoms, also known as a diatomic molecule, is polar or nonpolar. But what if a molecule has more than two atoms? In that case, we cannot use a difference in electronegativity. And that's because the shape of the molecule is a factor in the polarity of the molecule. So recall from our exploration, we explored the polarity of two molecules with three atoms. In the second molecule that we actually looked at, we looked at this bent molecule here. This one was polar. So when we set the electronegativities of atoms A and C to the highest setting and B to the lowest setting, we got a polar molecule in this bent shape. However, when we did the linear molecule, it was nonpolar. So in this shape, with the same exact settings, it's nonpolar. And that's because in the linear case, the bond dipoles, which are those black arrows here, cancel out. They're going in completely opposite directions, so they cancel each other out. So all of that was to show that the shape of the molecule does matter. It's not just about the electronegativities, it's also about how those atoms are arranged. Now, we don't know how to predict the shape. There is a way to do that. It's called the VSEPR theory, which is something that you can learn if you're interested in the extension activity. However, we're not going to be covering that here. So in our case, we're going to have to learn some sort of shortcut for predicting polarity of simple molecules. The other thing that we're going to cover, and this we'll cover in Part 3, is how the polarity of a molecule is related to its solubility. So when I say solubility, I'm talking about whether or not it dissolves in water. So what is the shortcut that we use for a molecule with more than two atoms or three or more atoms? The shortcut we use is this checklist here. So it may be a good idea to just sort of read through the checklist, pause the video, and just read through it before continuing. All right, so according to that checklist, a molecule is nonpolar if all the terminal atoms, which are the atoms on the end, are the same, and there are no lone pairs on the central atom. The other thing that this shortcut shows us is that hydrocarbons, which are molecules with carbon and hydrogen atoms only, are always nonpolar. And ions, anything with a charge, will always be polar. So those last two things were things we sort of have to keep in mind as exceptions to the checklist. Now, in order to use this checklist, however, we need to know what's our central and terminal atom. And for that, we would need the Lewis dot structure, which is something that we learned about last week in week 2 of Unit 4. So let's take a look at this first example. Is PF3 polar or nonpolar? So I give you the Lewis dot structure here. And notice that the terminal atoms are fluorines, because they're the ones on the end. And the one in the center is the phosphorus, our P. All right, so let's go through this checklist. Are all the terminal atoms are the same? Yep, absolutely, because I only have fluorines on the ends sticking off of the phosphorus, and no lone pair in the central atom. Well, let's take a look at the central atom, our phosphorus. See these two dots? Those are lone pairs. So my central atom here has a lone pair. That means I cannot check off that last thing. So because I can't check off the no lone pair thing, then guess what? This molecule is polar. Remember, this checklist is for nonpolar. So in order for it to be nonpolar, you have to check both of these things off. Since I can only check off one, it's polar. All right, looking at this example, is CH2O polar or nonpolar? So my central atom is carbon, and then my terminal atoms are hydrogen and oxygen. So are all my terminal atoms the same? Absolutely not. I have two types of terminal atoms. I have oxygen and I have hydrogen. So that automatically makes this polar because I couldn't check off both of them. Now, just a quick note, when you're doing that check, the types of bonds don't matter. If I have a double bond, triple bond, that doesn't matter in this case. You're only focusing on the atoms anyway. Now, the last item on this checklist I can check off, there are no lone pairs, there are no dots, double dots, or pair of dots on the carbon. But since I could only check off the one and not the other, this is a polar molecule. All right, is PCl5 polar or nonpolar? So let's go through the checklist. Here's my molecule. Are all the terminal atoms the same? Yep, I only have chlorine, so check. No lone pairs on the central atom. I don't see a single dot or lone pair, which is a pair of dots on the central atom. So then, yep. Remember, I ignore the lone pairs on the terminal atoms. They don't count for that second box, right? So it's just the lone pairs on the central atom. So this would be a nonpolar molecule because all the terminal atoms are the same and there are no lone pairs in the central atom. All right, last example is C2H4 a polar or nonpolar molecule? All right, so looking at this molecule is a bit strange. There are no central atoms here. I'm maybe a little bit confused at this point. Like, what am I supposed to do? When you see something that doesn't match quite what you are used to, take a look at these exceptions at the bottom. Then this one says if a hydrocarbon, which has carbon and hydrogen atoms only, it's always nonpolar. And that's what we got going on here. Look at this molecule. It only is made up of carbon and hydrogen. So in this case, this is going to be nonpolar because it's a hydrocarbon. All right, now that you've seen these examples, you're going to try this CFU. Is CO2 polar or nonpolar? Pause the video now. When you press play again, the answer will be revealed. All right, so the answer is nonpolar. We actually already seen CO2 before. So remember, all the terminal atoms are the same. It's just made up of oxygens. And there are no lone pairs on the central atom. Remember, lone pairs are these pair of dots that represent electrons. All right, CFU3 is NH2Cl polar or nonpolar? Pause the video now. When you press play again, the answer will be revealed. Okay, see, NH2Cl is polar because the terminal atoms are different. And there's a lone pair on the central atom. So terminal atoms H and Cl, they're two different types. And there's a lone pair on that central atom, nitrogen. All right, CFU4 is C6H6, also known as benzene, polar or nonpolar? Pause the video now. When you press play again, the answer will be revealed. So this molecule is a hydrocarbon. I know it's a hydrocarbon because it's only made up of carbon and hydrogen. Hydrocarbon, right? So, and those are always nonpolar. How about H2O, polar or nonpolar? All right, so in this case, the terminal atoms are the same. However, the central atom, oxygen, has lone pairs on it, so this is nonpolar. Sorry, this is polar. This is polar because it has lone pairs in the central atom. All right, so let's just quickly recap. How do you tell if a covalent molecule is polar or nonpolar? Well, of course, that depends on the molecule and the number of atoms in that molecule. Remember, if you're dealing with a molecule with two atoms, like these examples here, we use the differences in electronegativities and that table to figure out if it's polar or nonpolar. On the other hand, if we're dealing with something with three or more atoms, we're going to use this nonpolar checklist to figure out if it's polar or nonpolar. Let's see if that makes sense. So which of these molecules would you use the checklist to determine if it's polar or nonpolar? So pause the video now. When you press play again, the answer will be revealed. Right, the answer is choice C. So the reason why it's choice C, O3, which is ozone, it's because it's the only molecule with more than two atoms. Ozone has three atoms in it, so we could use that checklist. But the other choices only have two atoms in it. All right, so that's it for this video. In part 3, we're going to learn about this likes dissolves likes rule. Have a quality day.